from Friday that has sine and cosine at the top. So it was along this guy here. So if you could take out this was your homework to graph sine and cosine. Like that. And then in your notes packet, the really thick notes packet that you got on Thursday, if you could turn to page 2. We did the chart, we started the chart together on Thursday. I asked you to complete it. You needed to complete it so you could get the graph. And then if you look at page 2, there are questions on number 3 of page 2. And we're going to answer those questions using your beautiful graph, or mine that I have up here as well. Today we're starting to graph sine and cosine. So essentially we're taking that wonderful unit circle, we're pulling it apart and plotting the angles as the x-axis. So all of the angles will be the x, and then we're plotting the corresponding value that you get when you have the sine of that angle. So that it comes out to look like a beautiful wave, as if you were in the middle of the ocean floating on a nice big cruise boat, and there are no storms in the area. It's just a beautiful day, and you have that rolling current that happens when you're in the middle of the ocean. No peaks, crashing waves, just the nice bouncing back and forth. Maybe in the middle of North Park that happens every once in a while in their lake. There's a little bit of current to it, but it's just that nice ripple effect. So that's what our unit circle creates when you pull it apart and you graph the x values as angles and then the corresponding angle. Now, we don't graph them together. So that ordered pair that you have memorized, you're now just thinking of one of the values of the ordered pair. So in this case, I should ask you questions because you always ask me questions.
I stopped asking you questions. My questions were super easy.
Oh.
What?
So you can't tell me the cosine of pi over 4 then?
Cosine of pi over 4?
Yeah. See? He doesn't ask me questions anymore though, so I shouldn't have him, except he steals my pen.
No, your students steal your pens.
Ray did it on Friday. It was him.
Told you, don't blame me. Don't blame me.
He teaches in here second period, and then I come in third period.
And then I come back in 5th, and I come back in 6th.
Yes. But he usually like walks off with these, and I come in, I'm like,
You just wait. One of these days you're going to come in, and your board's going to be gone, or the board's going to be upside down.
yeah, that might happen too. I'm a really nice roommate.
So you give me a hard time.
Yeah. But he puts them in his pocket. Every time he like picks one up and then puts them in his pocket, and then he just picks another one up, puts them in his pocket, and then he goes to another room and he's like, how did I get all these pens? Because he puts them in his pocket. I never put anything in my pocket besides my phone. Who needs to put markers in pockets? Who does that? Mr. King doesn't do that. That's why I married him and not that guy, right? It's a key thing to remember. Do you steal markers?
Don't marry a man who puts markers in.
Exactly. If you steal markers. All right. So looking at the graph that hopefully you tried to create, this is your sine graph. We label these values on Thursday, and mine are kind of squished in there, but I tried to make them as neat as possible and color-coded so that you can see all the angles. But you have 16 points plotted from 0 to 2 pi because there are 16 angles from 0 to 2 pi. Will you ever plot all 16 of them again? No. We'll be talking about 5 important points, and I call them 5 key points that we will be focusing on. Because when you make a t-chart, for a typical graph, like y equals 4x squared, you pick 5 points if you're just making a t-chart, you plot 5 points. So, but, yes. Yeah, the ones we're going to be focusing on are going to be the quadrant angles. So, on page 2 of your packet, there are questions that I asked Mr. Cummings not to erase, and he was really nice. He did not erase them. So if you look at your questions, so this is part 3 of the page. The first question says, what is the domain? And we're just going to look at sine right now. So you have a graph on your page. You have a graph up here on the board. But what do you think the domain of a sine graph is, Chelsea? Right. So any sine graph has a domain of negative infinity to positive infinity. So just like a typical graph, you graph what you can on a grid, but it goes beyond the graph paper. This goes beyond 2 pi because you can spin around the circle an infinite number of times. 4 pi exists, 10 pi exists, 20 pi exists, 100 pi exists. So sine, the angle can be anything, and that's what the domain is. So when you're thinking about the domain, we're thinking about the angle values. So what happens with the angle? So they can be infinite. Brandon, what do you know about the range of the graph? How high, how low?
-1 brackets to +1 brackets.
Nice. Because the top of the graph is up at 1, the bottom is down at 1, and that's the highest or lowest it goes. It just goes in between those two numbers. The next question is even or odd, and you had to remember a little bit about being even or odd. Brandon, what do you remember about graphs that are even?
If graphs are even, they have a y-axis symmetry.
Nice. So even graphs have y-axis symmetry.
Odd doesn't.
Odd graphs don't. They have what kind of symmetry? Virginia? It is. Functions are either even or odd. Well, they could be neither, I guess. But if they're symmetrical, they either have even y-axis symmetry or they have odd original symmetry. If it has x-axis symmetry, it's not a function. And if it doesn't have symmetry, it just means that it's not even or odd. But there's only 2 types of symmetry for functions. So Brandon, in this case, is sine y-axis symmetry or original symmetry?
Origin symmetry.
And why is that?
Because the positive y values do not equal, because if you flip it in half, it's not the same.
Okay, so he said if you flip it in half, it's not the same. The y-axis definitely doesn't give you a mirror image. So the left side of the graph is not the same as the right side. However, original symmetry focuses on the origin, which it does go through the origin, and this part of the graph in the first quadrant is a reflection in the third quadrant. That's what original symmetry has to have. The first and the third, the diagonal quadrants are reflections of each other. So you have a curve that looks like a hill, it reflects and turns into a valley. And it works the same way. For the fourth quadrant, we have the valley. In the second quadrant, we have that bump up of the hill. So this is an odd function because it does have original symmetry. So then the following 2 questions talk about the max or the min, just looking at the positive half of the graph. Eris, the positive half over here. What angle gives us a max value? Okay, pi over 2 and 1. So at pi over 2 and 1, Eris, I won't call on you again. We have our maximum value. Now, yes, we could write the -1 as well, because right here, at -3 pi over 2, we also have a max. But I'm just going to focus on the positive part of the graph, because that corresponds with the values in your chart. So then, if we have a min value, Virginia, where would the graph give us a min value? What angle? Yeah, so 3 pi over 2 has a value at -1, so that would be our min. Max and mins are called critical points of the graph. They're important because they tell you where the highest and lowest part appear. When you're graphing, you kind of need to know where that happens, the highest and lowest part of the graph. So the next 2 words, probably you don't know what they're talking about. We're going to kind of define them over the next couple of days. But the first one is called the amplitude. And it tells you how to find the amplitude. It says you need to take the max minus the min and divide it by 2. Today we'll talk about the amplitude being the distance between the center of the graph and the top, the peak, or the center of the graph and the bottom. But we can calculate that, Brandon, by doing what?
Would the answer just be 1?
Yeah, because the max is 1. The min is -1, so 1 minus -1 is 2, divided by 2 gives you 1. Corresponding with the graph, the distance from the center to the top is 1. That's what the amplitude is. So pretty much it's how high is the curve? How high is the wave? How low is the wave? So the amplitude, the distance from the center to the top is 1. So that's the amplitude. So it's kind of like the stretch of the curve. It will always be positive because it's a distance, yes. So it's a distance that it's stretching vertically. Other questions? The next term, also a new term, is called the period. The period is one rotation of the graph. We also call it one cycle of the graph, one spin around the unit circle, because this really goes back to the unit circle. So if you rotate around the unit circle, how far are you going in one rotation? 360 degrees, or 2 pi. So one rotation around the unit circle, from start to finish, we start at 0, we end at 2 pi, and then we rotated and calculated all the angles of the unit circle. That's called a period. So in a graph sense, we're looking from the start to stop of the graph. So where does it start, where does it stop? That shape that you get. So from the starting point of the angle of 0 to the ending point of the angle of 2 pi, that distance is called the period of the graph, and that's just 2 pi. Libby, how about an x-intercept? What do you look just on the positive side? What x-intercepts do you see?
0, 0, pi 0, and then 2 pi 0.
Yeah. So the x-intercepts are where it touches the x-axis, and there are 3 of them on the positive side of the graph. Those are also important points. So when we graphed parabolas, when we graphed polynomials, when we graphed logs and exponents, those are the things that we focused on finding: the max and the min, and the x-intercepts, the y-intercepts. So those are all important pieces of the graph when we're trying to look at the graph. So because of those being important parts, those 5 ones that I circled, those are called our 5 key points. You will no longer be graphing the 3 in between all of them to get another 12. But instead we'll just be graphing those 5. So the 5 key points for the sine graph. So the x is the angle, and then the y is the value of sine at that angle. So 0, 0 is our first x-intercept. The max occurs at pi over 2 and 1. That's an important point because we need to know how high the graph goes. It's a critical point. It's an important point. I call it a key point. The third important point, key point, is at pi because it's another x-intercept. The fourth one is at 3 pi over 2. That's the minimum value at -1. And then when we spin one full rotation around the circle, we're back at 2 pi, or the value of 0. Every sine graph starts with those 5 points. They need to be memorized. You already have them memorized, but you have them memorized as on the unit circle. So at 0, at pi over 2, at pi, at 3 pi over 2. That's how you have them currently memorized. So now we're going to memorize them as a set of points to create a sine graph. So every graph we do will start with those 5 set of points. And then we're going to just start changing them by translating them a little bit, shifting them, stretching them, shrinking them. But they go back to the 5 points. So everything will go back to those 5 points. The last 2 words. Does anybody know how to say that S word? You're really close. It looks like it should be a short out vowel sound, but it's actually a long. It's sinusoidal. It looks like it should be a short vowel. So it's a sinusoidal axis. The sinusoidal axis is the horizontal line that cuts the graph in half. I have mine dashed up here in red. So the sinusoidal axis is like the middle of the graph. What line represents the middle of the graph? Well, that's the line y equals 0. So at y equals 0, that is called our sinusoidal axis. So you have half the graph on top of it, you have half of the graph on the bottom of it. So it's the center horizontal line. Always horizontal, it's always y equals. Splits the graph in half. That will move when we start shifting the graph up and down. So that is not always at y equals 0. For now, for the first 3 days, it'll be at y equals 0. The last one, the frequency, is how often the graph repeats itself. And it says to take 1 divided by the period. So 1 divided by 2 pi, that just means 1 rotation every distance of 2 pi. After you get to 2 pi, the graph repeats. So you're going to see the same graph over and over and over again. So the part on the right side here, this is the graph. This is 1 rotation of the graph. We actually have 2 rotations of the graph up here. You'll be asked to graph 2 for every graph. So you'll show points for 1, you'll just plot points for the next one because it's pretty much a repeat. So when the directions say to graph 2 full periods, include 5 key points, you'd have 5 points, but 2 pieces of the graph would be shown. Questions? All right, so we're going to quickly go through the other questions. Now we're just shifting over to cosine. So if you look at your cosine graph, or kind of look at the one that's up here, we're going to answer the same questions, but we're going to answer them for cosine. So you can kind of see the similarities and where the differences might occur. What do you think the domain of cosine is? Yeah, the domain is the same. Negative infinity to positive infinity. Sine doesn't stop at a specific angle. Cosine isn't going to stop at a specific angle. What do you think the range is? Right, it has the same range as well because the highest and lowest points are still at the values of 1 and negative 1. It stretches up to 1, it goes down to negative 1. Brandon, is the cosine graph even or odd?
Even.
Why is it even?
Because y-axis symmetry.
Yeah, so this graph has y-axis symmetry. Right here, the y-axis cuts it in half, and you can see that really nicely. So it makes a big W, but it's like 2 cursive V's put together when you think back to cursive. You've got 2 of them stuck together. All right, so Nick, where's the max happening on this graph? What angle does that happen at?
0.
Mm-hmm. So at 0, it's at a max of 1. And
2 pi.
2 pi, it's at a max of 1. And again, we'll just stick with the positive side. So Nick, the min occurs at
Pi.
pi, nice, in the middle. So sine starts in the middle of the graph. It starts at 0, 0. Cosine starts at pi and ends high. So it starts at the max and ends at the max. So that's where they're a little different. The sine starts in the middle and ends in the middle. The cosine starts at the max and it ends at the max value. That's because of that ordered pair, the location of the unit circle. So a couple other questions over here. Brandon, does the amplitude change because it's cosine? No, it's still stretching a distance from the middle up to the top of the curve. That distance is still 1. Or from the middle down to the bottom of the curve, that's still 1. That's your amplitude. So that distance is still the same. The period, 1 rotation around the graph. Well, you're still starting at the angle of 0 and ending at 2 pi, so that part's not changing as well. Still 2 pi. Sabrina, how about some x-intercepts for cosine?
There's 0, not 0, pi over 2, 0.
Good, pi over 2, 0.
There's 3 pi over 2, 0.
Perfect. 3 pi over 2, 0. So we now have max, 2 of them, a min, and then our 2 x-intercepts that would create the 5 points for cosine. So the angles are the same. We're still using the angle of 0, the angle of pi over 2, the angle of pi, 3 pi over 2, and 2 pi. But the y values are what's changing because the cosine of those angles are different than the sine of the angles. So thinking of the ordered pair, if I put both graphs together, then I have the x, y values from the ordered pair. So the angles will be the same. Those same 5 angles are called the quadrant angles of the unit circle. Answering the last 3 questions underneath, the y-intercept is 0, 1 because it starts at the y-intercept. The sinusoidal axis is still at y equals 0, and the frequency is still 1 over 2 pi. So the pieces that change from sine to cosine would be the important points, the locations of the max and the min, the location of the intercepts. That's going to be the difference between sine and cosine, which creates a different curve. So the shape of the curve looks different because of the y values changing. So what we're going to do today is we're going to try and graph just a nice graph for each of these just to get you to kind of used to how to graph. And then we're going to look at two graphs that change the amplitude, so that stretching part. Instead of it going up to 1, what happens if we stretch it higher, or what part of the equation makes it kind of squish and shrink? So that's what we're going to just look at today. To kind of get you to focus on what the y, the key points are, and how those key points could just change with the y. Brandon?
If you were to find the inverse of a function, you do the horizontal line test, right? To see if it has an inverse. These have it, sine and cosine have inverses, right?
They do.
But why, if it fails the horizontal line test?
We'll talk about that in section 4.7, I promise. Just not right now. You can always restrict a domain, like every parabola fails the horizontal line test, but we restrict the domain to only have a certain piece of the function to have an inverse. But we'll go over that in 4.7, I promise. I won't leave anything out, Brandon. So if you could turn to page 7 in your packet. This is the part where it gets like confusing. Since my packet, of course, none of the packets that I asked for can be printed nice and neat. So on page 7, if you look at the top of page 7, you have y equals sine, y equals cosine. We're going to graph 5 points and get a nice, neat, clean graph so that you can kind of see how every graph will be done. Except when you look at the graph that's drawn there, there's pretty much a non-existent grid. So on the graph paper that you picked up, I asked you to pick up 2 pieces because the one is going to be for the notes and then the other is for homework. You have 3 graphs that you'll do tonight for your homework. We'll probably graph 3 or 4 right now in class. So 3 graphs for homework tonight. You'll use one of the sheets of graph paper and then we're going to use the other as notes. So you'll always have a page of notes of graph paper, unfortunately, just because the grid isn't there. So on the graph paper that you picked up, at the top, maybe remind yourself that it's notes, whatever you want to do there. But if you can put y equals sine of x at the top of the first graph, just y equals sine x. And these are way bigger than I thought they were going to be, so I'm going to try and make them a little smaller for tomorrow. I mean, it's nice that they're large, but that's a little too big. So we're going to graph 5 points for the sine. Those 5 key points that I just went over. And it starts with the angle of 0. And then in your brain, just think about, or maybe you have it memorized, what is the sine of 0? Because that's the y value. So what is the sine of 0? Chelsea? 0. So that would be our first key point. The second key point will be the angle of pi over 2. That's the angle that's at the top of the unit circle. So in your memory, get a little picture in your brain, think of a unit circle. Chelsea, what's the sine of pi over 2 on the unit circle? 1. Because that's when you're at the top of the unit circle vertically. You have a distance of 1. And then the next angle is just pi. So now we're over here on the left of the unit circle. Michael, what's the sine of pi? 0. All right. 3 pi over 2 would be the next quadrant, which is down at the bottom of the unit circle. Michael, do you know what the sine of 3 pi over 2 is on the unit circle? Negative 1. And then when you get back to 2 pi, you're back at 0. So I'm just getting those quadrants. So the quadrant angles of the unit circle are the ones that we're going to think about and memorize. When you go to graph it, we're going to graph pretty much all of these in the same manner. So for the x-axis, that's our angle. We're going to count by pi over 2. 3 spaces just to keep them spaced nice and even. So you get a nice pretty stretch of your graph. So those angles, those 4 angles, I really don't need to list 0. So we're going to go over 3 spaces, pi over 2, 3 more pi, 3 more, 3 pi over 2, and so on. You can put tick marks on the left side. You don't have to label the left. And then for the y-axis, generally we count up 4 spaces and call that 1. Again, that's just so that you have a nice stretch of the graph to kind of physically see what's going on with the curve. Otherwise it gets squished and you have no curve because your y is just counting by 1. So plot the 5 points starting at 0, 0. Make a nice smooth curve when you connect them. As best as you can, make it curved, smooth. So this is 1 cycle around the unit circle. This is 1 period. We're going to make another one just by taking that and kind of doing the other shift, the other portion of the graph. A thing to remember is that a hill, do you want to go get a drink? Are you okay, Eris?
I have water.
Okay.
It's just like
It's just, yeah, I got it. So your hill and then valley, or the wave has to go up and then come back down before it can go back up. So you should never have 2 hills next to each other. It should always be a hill and a valley. Think of the wave in the ocean. It goes up and down and up and down. Or a roller coaster, like the jackrabbit, the end of the jackrabbit. A whole bunch of those nice hills up and down, up and down. Sine graph right there. So when you ride the jackrabbit next year, you're riding the sine graph. Think about that. Great conversation to have while you're riding the jackrabbit. And then underneath, just a reminder, it's an odd function because it has original symmetry. Questions? So see if you can correlate the 5 key points for cosine as well. So it still starts at 0. Your angles should not change. It's the y values that change because now it's cosine. Libby, do you know what the cosine of 0 is?
1.
Good. How about pi over 2?
0.
Pi.
-1.
3 pi over 2.
0.
And then 2 pi. They gotta like rotate. I mean, 1, 0, -1, 0, 1. And then they're gonna keep doing that. Just a repetition. 1, 0, -1, 0, 1. 0, -1, 0, 1. 0. They just keep going on and on and on. It's like a little repetition there. Always 3 spaces. Over 3 spaces, put a little tick mark. That's an angle. And then this graph starts at the max, works its way down to the min, and then works back up to get to the max. So it should look like a cursive V. This has a y-axis symmetry, so you should just take this exact graph and you're just repeating it so that you have 2 cursive V's that connect to be a U. That makes 2 cycles, 2 periods of the graph. So they are exact identical pieces because it has y-axis symmetry. So what we're going to do is we're going to take these 2 beautiful graphs that you now have drawn, and we're going to talk about the amplitude and how that could change, just tweak it a little bit. So that's the first value that we're going to talk about when we're looking at an equation. The amplitude is the A, the number in front of the function. So if you go back in your mind, when we talked about parabolas. This was the a value, the number in front of x squared. It told us the graph opened up if it was positive, down if it was negative. It does the same exact thing for sine and cosine. So just because we're doing trig functions doesn't mean the process of graphing changes. So this is a vertical stretch. Or a shrink of a graph. That's what the amplitude does. So it's actually called amplitude in sine and cosine. It doesn't really get a name when you're talking about a parabola. We just say it's a vertical stretch. But for sine and cosine, it's the actual stretch of the graph from the center to the top of the wave, from the center to the bottom of the wave. So that number is always stretching the graph vertically, which means it affects y. So if we're stretching the graph vertically, we're affecting the y value. Underneath, you see a couple of extra variables. We'll talk about those tomorrow. Each letter does something different to the graph, so every day we'll just go over a different letter. But underneath that, it says if it's the a value is between 0 and 1, it's squishing it vertically. If it's between, or above 1, I should say, then it's a vertical stretch. It's stretching it, pulling it vertically. So we're going to look at the 2 at the bottom. Again, if you just take your large graph paper and flip it over, at the top of the first one, you can write y equals 1/2 cosine x. So I'm going to list the 5 points, but just focus on the angles right now. So the amplitude affects y because it's a vertical stretch or shrink of the graph. Anything vertically shifting is always y. So even if we're moving something, we're moving the y values, we're shifting the y values. So Libby gave me the 5 cosine values a couple of minutes ago. I'm going to write those values outside of the parentheses just as a reminder of what they're supposed to be. So cosine usually has a y value of 1, 0, -1, 0, +1. So cosine starts high at 0, it ends up high at 2 pi. What happens if we're multiplying 1/2 in front of cosine? Bryn? You're dividing it by 2, or you're just taking 1/2 times y. That's what this 1/2 does. And way back in chapter 1, when we had a number in front of the function, we took that number and multiplied it by the y values. That's like section 1.1 and 1.3. So we're going to take half of y. So my new y value is 1/2. Half of 0 is just 0. Half of -1 is -1/2, and then 0, and then back at 1. So whatever your original y value is, that 1, 0, -1, 0, +1, is now 1/2. So we're going to graph it the same exact way. Still go up 4 for the y-axis, go down 4 for -1. Over 3 spaces, call that pi over 2. And then you're plotting your points. So you have your 5 points in your t-chart, we just have them as ordered pairs. We no longer write them as t-charts. If you want to write it as a t-chart, that's fine. So we're starting up at 1/2. Moving down to 1/2. Ending at 1/2. So the graph should look the same. It's just squished. It's shrunk. It's not nearly as high as it was. It's half of the distance instead of the full distance. And again, just mimic that on the other side of the graph so that you have 2 portions graphed, 2 cycles. So now we have a cosine graph that's half cosine instead of regular cosine. The other graph is y equals 3 cosine x. So the x values are the same exact x values. So we still have 0, pi over 2, pi, 3 pi over 2 and 2 pi. Except if you're multiplying by 3, what happens to your y values? You multiply them by 3. So instead of it being 1/2 for the first value, it's now 3. And then 0, and then -3, and then 0, and then +3. So whatever number's in front is changing the y value of the graph. You're multiplying by the y of the graph. The x values are not changing. It's the same exact angles. So mine goes off the graph by 2 if you continue to count by 4. So this graph should be stretched. It should look really tall. And that's because of the 3 in front stretches the graph. So hopefully today makes a little more sense now that you see what the graphs look like. Tomorrow we'll be doing a little more with the graph. We'll be affecting the angle tomorrow, not just the y value. So again, you have 3 graphs to do. Please make sure you're writing points with your graph. You have 2 graphs. The other questions are more just kind of interpreting, explaining what a piece means, talking about the terms that we've discussed. Have an awesome day. If you won't be here tomorrow, I'd say pick up like another 2 or 3 pieces of graph paper on your way out, or you're coming at the end of class, just pick it up now. Have a great day.